All right, welcome back. Lesson 73, applying trigonometry. Okay, so we're going to take those trig things we did a week or so ago and we're going to make some applications. Okay, not hard, you just kind of have to remember some things. So I'm going to first write up our wonderful acronym, just so TOA. Do you remember what that meant? What that means? It means sine of some angle. I usually put a theta. You can put x, you can put a, you can put anything you want of something unknown is the opposite over the hypotenuse. Okay? That is so. Extra little lines, take those away. Ca means cosine of some angle equals the adjacent over the hypotenuse. Okay? And TOA means tangent of some angle is the opposite over the adjacent. That's a little refresh piece that we know. Okay? So we're going to talk today about how we can apply this SOHCAHTOA. Okay, I'm sorry, my brain, I was taught SOA, which some of my kids got very angry with me. I think it was my southern accent so much, SOA. But it's SOHCAHTOA. Remember that, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We're going to see how this can be applied, okay? I do say trig is the most applicable math to everyday life. Just saying. It's one of my favorites. But some other things that we need to know. We need to talk about the angle of elevation. The angle of elevation. What do you know elevation is? It's the height of something. Okay? The definition says it's the angle formed by the horizontal line and a line of sight to the point above. Okay? It's an angle formed by a horizontal line and a line of sight to a point above. Okay, elevation means we are looking up. Okay, we are looking up. So, what does that look like? I'm going to draw them both in just 1 second. So, here we go. I'm going to scroll down just a little bit. And we're also going to talk about the angle of depression. Okay, so I'm going to put down here, I'm going to draw in between of depression. Not spelled so well. Angle of depression is the angle formed by the horizontal line and the line of sight to a point below. So these definitions look very, very similar. What is different? One word. Elevation, you are looking up to a point above you. Depression, you are looking down to a point below you. Okay? How would this work? Okay, so I'm going to draw a building. Okay? And we're going to pretend, okay, this is me. I'm going to be a person. I'm just going to put a P for person. Okay? And I'm standing on top of the building. I'm on the roof. And I'm looking down to a point on the ground that's farther away. We're going to call it a turtle. Okay? So I'm looking down from my line of sight. Generally, where is your line of sight coming from? Generally, it's coming from your eyes, right? So it would be how tall I was, Sometimes they'll be very specific and just say from the top of the building. Okay, but if I'm standing on the building, I'm looking with my eyes and I see a turtle. Okay, but something else it talks about is this horizontal line. What horizontal line? It's an understood horizontal line coming from your eyes. Okay, so we have to have that point from our eyes horizontal. And if we are looking down with our eyes at this turtle at a point below, our angle of depression is this angle up here. Okay, it's on the outside of the angle. Okay, now on the other side of the building, down the street, somebody is standing and looking up. They're sitting in their car. I don't know. So here's somebody sitting in their car. They look out of their window and they look to the top of the building to see I don't know, there's a flower or a tree growing up there. And they want to know the angle of elevation. So they are on the ground in a car and they are looking up at a point above. Okay? There's also a horizontal line from their line of sight, okay, which will be on the ground. So from their line of sight, the horizontal line is always going straight out, okay? The angle of elevation is inside this triangle where they are looking up. Okay, so that's how we can see things. They talk about an airplane. When you're looking down and seeing a lake or a tree from an airplane, you're looking down at an angle of depression, okay? If you're on the ground looking up, you're looking at a kite, you're looking up at that airplane, you're looking at an angle of elevation, okay? Now, big question is, what are all these horizontal lines? How are they related to each other? Okay, this horizontal line from my line of sight up here, and this horizontal line from my line of sight in the car, and maybe even just the ground. We're going to assume that the ground is always parallel to the horizontal line. Okay, so this line is parallel to this line, is parallel to this line. They're all parallel to each other. Okay. Why does that even matter? Well, it matters in the case of this angle of depression up here is on the outside of a triangle. Maybe somebody asks, well, how far is this person off the ground? Okay, I give you a little bit of information and we can find out that information. But the purple line, the angle of depression, is outside my triangle that I might draw right here. Okay, so if I want to find information about that triangle, then I have to put that angle of depression into my triangle. Well, if all these horizontal lines are parallel to each other, what do we know about this angle right here? If these lines are parallel, what is parallel to that? We have alternate interior angles that are congruent if the lines are parallel, okay? So that angle of depression is going to go right there inside my triangle, okay? Little hint, they will always be inside the triangle, okay? And 99% of the time, they're going to be at the bottom, okay? That's where we're going to talk about them. All right, let's look at a problem. Use the angle of elevation between the kite. Sorry, we're going to that. Between the kite and the child to find the horizontal distance between the kite and the child. So I'm in here. I'm looking. There's a little person, and they're holding their arm out, and there's an angle of elevation that is 36 degrees. And her kite is up here at the end. They tell the angle of elevation is 36 degrees. This is example 1 if you didn't know. The string of the kite, they tell you, is 80 feet long. Okay? It's wanting to know. Find the horizontal distance between the kite and the child. Horizontal distance is what? Horizontal is always on the horizon. Okay? So what is the horizontal distance between the child and the kite? Now, do things always are going to come down at a right angle? Yes, they will. Okay? They draw little dotted lines just to make that happen. Okay? So, we did a few of these in our trig problem, in our trig when we did it earlier, but we have to know something. We have an angle given to us, yes? Yes, it's 36 degrees. Could we find the other one? Yes, but do we need to? No, we don't. Okay? Looking at this angle that's 36 degrees, what am I given? What is that 80 feet? Is that the hypotenuse? Yes, it is. Okay? What about what do we want? What is this x? Is it the opposite? Is it the adjacent? You only have 3 choices. Opposite, adjacent, and hypotenuse. The x is the adjacent. Okay, so how can we solve for x? What trig function relates an adjacent to a hypotenuse? Right, it's that CA. Adjacent over hypotenuse. So it's cosine of what angle? Wait, we're given the angle. Cosine 36 degrees equals adjacent over hypotenuse. How do we solve for the adjacent? How do we solve for x? Any number equals x over 80. How do we get x by itself? We're going to multiply both sides by 80. Okay, I'm going to pull my calculator up. It'll take it just 1 second. 80 divided by 80 is just 1. So we have x equals. Now I'm literally going to plug in my calculator, 80 cosine 36. If it will pull up. It's slowly pulling up. I'll have to move it to one side or another. Erase that little extra dot. And it's going to be slow. I'm sorry I haven't pulled it up today. So I just want to show you what it's going to look like to plug into your calculator. I'm going to scroll this way so I can see the problem. I'm just going to put 80. I'm not even going to put a time sign. It knows if it's beside it, it will be times. Cosine 36. I don't even have to close that parentheses because it's an extra button. So what is 80 cosine 36? It is 64.72, etc., etc., etc. Is approximately x, or the horizontal distance. We probably even need units. It was feet. Units are important. Okay? 64.7. Oh, they do give me 2 decimals. Okay. All right. Can you do another one? I'm going to minus that down. I have a building. And I know that part of this building, we're going to draw the building here, there's a balcony that somebody is standing on about on the 4th floor. And we know the 4th floor here is going to be 40 feet tall. Okay? And there's a person standing off on the way. This building is going to come down at a right angle. And the angle of elevation from someone standing on the ground to an apartment balcony 40 feet above is 42.6 degrees. 42.6 degrees. Okay? How far is the person from the balcony? Okay? How far is the person from the balcony? So this person is standing or sitting on a park bench right here. The big question is, what are they asking for? How far is the person from the balcony? They are asking for the hypotenuse. Okay? Okay, so sometimes the wording can be a little confusing. Okay, so I'm going to go ahead and put this here. So how far is the person from the balcony? And I'm really just going to draw that line so I know what I'm looking for. Okay, next question is, angle I'm given. What trig function do I need to use? I'm going to look at what am I given. I'm given this 40 feet here. How is that related to the angle? It's the opposite. You only have three choices: opposite, adjacent, and hypotenuse. Only choices you have. Okay? And then what about x? How is x related in this triangle? It's the hypotenuse. So what trig function relates an opposite and a hypotenuse? You're correct. It's so. Okay? So sine of an angle. Do we know that angle? Yes, we do. 42.6 equals the opposite over the hypotenuse. We don't know x. Now, is it that simple of multiply 40 by both sides? No. That's why you have to write this out. Write it out every time. Okay? Because you need to know, am I multiplying? Do I need to divide? How are we going to solve for that? Okay? So how do we solve for x? I think the last time we did this, we went through all of the long algebraic steps. Okay? There is a shortcut, remember? If we have this, the x can just switch places. Okay? X really equals 40 divided by sine 42.6. And if you don't believe me, go to the side and use your thought bubble and say, 12 divided by what equals 4? Okay? How do you find that out? 12 divided by what equals 4? Well, we all know it's 3, right? Because 3 times 4 is 12. But x really equals 12 divided by 4. Is 12 divided by 4 3? Yes, it is. Okay? Use your brain. So here we go. We're going to solve for x. I'm going to pull my calculator up again. So I'm simply going to say 40 divided by sine 42.6. And you might notice I am in degrees. Make sure your calculator's in degrees or you're not going to get the same answers and they'll be wrong. Okay? Equals 59.095, so I might say 59.1, okay? So x equals 59.1 feet. Is the distance from the person to the balcony. Could I have asked a different question? Okay, let's see. What colors have I not used? Green. Could I ask how far is the person from the building? Question mark. I'm going to kind of do a little. Could I have asked this question in green? How far is the person's still in the same spot, from the building? Well, where is the building? Right there. Is that a different question completely? Yes, it is. And then we have to use something different. I'm going to put a y there. So now, if I'm solving for y, how is y related to the angle we're given? 42.6. Is it the, you're right, it's the adjacent. So I already have the hypotenuse, if we weren't asked in this case. We could use the Pythagorean theorem, but we're going to pretend we don't have that. Okay? Can you use a trig function to find y? How far is the person from the building? Okay? So, now we are given the opposite, which is 40, and we're trying to find the adjacent. What should we use? TOA. Okay? Because tangent of some angle, do we have that angle? Yes, we do. 42.6 equals the opposite over the adjacent. We don't know the adjacent. Can you solve for y? Yes, you can. So, doing the same trick we just did, y would equal 40 divided by 10, 42.6. I'm going to pull my calculator back up, scoot it over. So I'm going to divide 40 divided by 10, 42.6. Are we done? It's 43.499, etc., etc. Y would equal 43, or be approximately 43.499 5 feet. Means the person is approximately 43.5 feet away from the building. We have just used trigonometry. Okay? Let's talk about if we're given an angle of depression or, so that was both kind of elevation. Okay? A pilot in a plane cruising at 33,000 feet sees a lake. If the angle of depression from the plane to the lake is 30 degrees, how far is the plane from the lake? Okay? So, what are we trying to find? Let's see. I need to draw because I like to draw. There is a plane, but my drawings are never any good. And we know that up ahead it sees a lake. Okay? And the angle of depression, which is on the outside here, is 30 degrees. Yes? If the angle of depression from the plane to the lake is 30 degrees, how far is the plane from the lake? What is it asking for? Okay, so what else do we need? What else do we have? Do we have this distance? Yes, they told us how high the plane was flying. 33,000 feet. Okay, what is it asking for? I'm literally going to take the words. How far is the plane up here from the lake that's down here? Okay, that's what we're looking for. Now, I have a triangle down here. I'm going to draw it in blue. Is my angle of depression inside that triangle? No, it is not. But we do know that this horizontal line of sight and that horizontal or the horizon, they're going to be parallel. We're taking that for granted. We're just going to assume it is. So if they're parallel, then the angle of depression goes down at the bottom. Okay? What are we given? We're looking at an angle. We know the what? How is that 33,000 feet related to that? It's the opposite. And what are we looking for? We're looking for the hypotenuse. Opposite over hypotenuse is the what? So sine of the angle, we know the angle is 30 degrees, equals the opposite over the hypotenuse. How do we solve this? We just did 2. They're going to switch. So x will equal 33,000 feet divided by sine 30. Okay? You might notice that this is a special right triangle, so it's going to come out at exactly 66,000 feet. Because it's a 30, 60, 90 triangle. The short side is 33,000. The hypotenuse must be 66,000. This has to be double. Okay? All right. They go ahead. They tell more things. This is another good one. We have 2 people that are standing away from a building. Okay? Person A, window washers working 60 feet above the ground. About how far away is each person from pictured at street level? Okay? So person on the top of the building, window washer, washing a building, and he is 60 feet. So this distance is 60 feet. And he sees person A, I'm going to pretend that they're here, at a 40-degree elevation, and person B, we're going to pretend that's 40 degrees, and person B as an angle of elevation that's 70 degrees. A little hint. The closer you are to something, the more the angle is that you're looking up at. Okay? We could ask a lot of questions here. How far away is each person pictured at street level? All right, so what do we know? Probably choose a different color than that. How far away? So really it's asking how far away is each person really from the street? That's not a good question they're asking. Okay, They're asking how far away is the person from the window washer. Okay. Another really great question would be, how far away are the people from each other? That's another great question they could ask. Okay. So let's solve all three of these. Could we do that? Yes, we could. All right. So what do we want to know? Well, first off, we know the building comes down at a right angle. Each angle, we know the opposite is 60 feet. And each one, we're looking for a hypotenuse. Okay? So we're just doing two different problems with two different angles. Okay? So we would use what trig function relates the opposite and the hypotenuse? You're right. So we would have sine of 70 degrees equals opposite over hypotenuse. Second problem, we would say sine of what angle? Yeah, this time it would be 40 degrees equals opposite over hypotenuse. And we would solve for both of those and get the answer. Okay? When they use the 40 degrees, they get 93.34. 93.34. I switched my X and Y's just so you know than the book did. I'm sorry. It's okay, right? All right. When they use 70 degrees, they got 63.85. 63.85 feet. Would that make sense that the person with a higher elevation is closer than the person that's farther away with a smaller angle of elevation? Okay? How could we solve for Z? How could we solve for this? How far are the people away from each other? Okay? Big question mark. Well, really we're talking about from the building to the people. Could we find how far this person is away from the building? Yes. And then could we find out how far A is away from the building and then just subtract them? Okay, so this distance from the building to the people is going to be the adjacent. And we know when we're dealing with adjacent and opposites, we're going to use TOA, correct. So I'm going to say tangent of 70 equals opposite over adjacent. I don't know, I don't have a letter for it. We're going to call it, we're just going to call it B. Okay? Switching that, we would say 60 divided by 1070. If we wanted to find the whole, this one I'm going to call it A. I would say 1040 equals opposite over adjacent. The A would equal 60 divided by 1040. I'm going to pull out my calculator, just 1 second. I'm going to scoot it over. So to find, I'm going to say 60 divided by, oops, I multiplied. 60 divided by 1070 is 21.838, etc., etc., etc. 60 divided by 1040 is 71. How far away are they? I'm going to subtract 71.5, 505, etc., 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 minus 21.838. If you want, you can go and copy that number. They're approximately 50 feet away from each other, or Z equals approximately 49.7 feet away from each other. Okay? We could find out who was farther away. I think that's a problem later. Okay? Trig is always fun. Maybe this, we usually do a little experiment. I put you in groups. Maybe I will video myself doing this. I have a little hypsometer. We use a protractor and a straw and some kind of weight. I've used like little clips. and you can actually find the height of things. Find the angle of elevation. Your hypsometer will give that to you. It's actually pretty fun. I'm sorry that we're missing it. Oh no, we're missing it. Maybe we'll do it in Trig when you get there. I don't know. All right, so few problems for homework tonight. So we have lesson 73. We're going to do the practice. And we're going to do a little bit different. We're going to do 7, number 7, number 11, and number 14 through 17. All right. I will see you guys again another day. Have a great one.